Call a positive integer n extra distinct if the remainders when n is divided by 2, 3, 4, 5, and 6 are distinct. Find the number of extra distinct positive integers less than 1000. So let's check n modulo these numbers. So if let's call n is equivalent to a modulo 2, then in modulo 4, this number is either a or a plus 2. So since the remainders are distinct, it cannot be a. Let's assume that n is b modulo 3. Then in modulo 6, this number is either b or b plus 3. Since the remainders are different, it cannot be b, it has to be b plus 3. And let's call this number is c modulo 5. Okay, so let's do a casework. When a equals 0, and a plus 2 is 2, and modulo 3 numbers are 0, 1, 2, and 0 and 2 are already used, so b has to be 1, then b plus 3 has to be 4, and numbers 0, 1, 2, and 4 are used, so c has to be 3 in order to residues in each modulo to be distinct. And when we work these numbers, we obtain that from Chinese remainder theorem. I just do a little bit of a construction and observe that this is true if and only if n is 58 modulo 60, where 60 is LCM of these numbers 2, 3, 4, 5, and 6. Okay. All right, so this is what we get in the first case. In the second case, a can be 1. If a is 1, then a plus 2 is 3. And then b is, and if b is 2, if b is, so if b is 0, b plus 3 is 3, this doesn't work. It cannot be 1, it has to be 2, right? So b is 2, and 2 plus 3 is 5. So this is 5. And now for c, we have two choices. It's either 0 or 4. Okay, for both, let's work for both cases. When n is equivalent to 1, 2, 3, 4, and 5, this is when n equals 59 mod 60. Okay, and when n equals 1, 2, 3, 0, 5, then this is if and only if when n equals 35 mod 60. Now, these are the extra distinct integers, and if you want to count extra distinct integers up to 1000, so let's write 1000 as 960 plus 40. So in 960, only three of each 60 is a extra distinct number, and from the remaining 40, only one of them, because the only one which is equal to 35 mod 60 works, the others would not work. So then the final answer is 48 plus 1 is 49. So our final answer is 49.